Hi, my name is Emmanuel Etukudo and I'm currently taking Physics 2212 at Georgia Tech, and this is my lab report on lines of charge. So the key ideas in this law are Coulomb's law, which basically describes the electric force between two charged particles a certain distance apart with a certain charge each. Electric field is the force field created by a charged particle. The electric field can be thought of as the force a small positive test charge will feel at a certain location, and hence the units for the electric field are newtons per coulomb. The force due to gravity is an attractive force, and for this lab is simplified for using at the Earth's surface. Line charges for this lab will be treated as a collection of point charges arranged in a line. And another key idea is E field superposition, which basically says that electric fields can be added vectorially and do not affect or block one another. The purpose of this lab was to understand the idea of charge, a property of matter, and to become familiar with the amount of excess charge on everyday objects. So here are the formulas used, such as Coulomb's law, an electric field due to a point charge, an electric field due to a rod or a line charge, and the relationship between the force and electric field, and the force due to gravity close to the Earth's surface. I'm not going to go over each of these formulas as they are all self-explanatory, but you may take a look at them if you wish. Here I also have a diagram of this setup where we floated tape B by holding tape A below it, and the separation distance between tape A and tape B, as well as the mass, length, and width of tape B are all shown to the right. As in the previous lab, I defined a function to calculate the electric field at a given location due to a specified charge. But here we'll be looking at the actual application of the line charge portion of the lab. So here I split up each tape into multiple point charges and then found each point charge on the top tape. I found the electric field due to each point charge on the bottom tape and then added all these electric fields together to find a net electric field on each and every point charge in the top tape. Let's take a look at the output. So in my code, I set n equal to 100, where n represented the number of point charges into which I split each tape. And I chose such a large number because I wanted to obtain as accurate a result as possible. As we choose larger and larger n's, our results become more and more accurate as we are effectively taking the integral of the function. More precisely, the green arrow shows in the diagram to the left are the net electric fields for each point charge in the top tape. Now you can see the magnitude of electric force we got was 1.87 times 10 raised to the power minus 3 newtons approximately, and the magnitude of the gravitational force was 1.94 times 10 raised to the power minus 3 newtons approximately. As for these assumptions shown, the first one does not apply as tape B is static once it floats, so air resistance on a moving object is irrelevant. The second assumption also does not apply as we actually treated each tape as a line charge rather than a point charge and do not concentrate the charge at the center of tape. We actually distributed the charge along the length of the tape. The third assumption does apply as we did assume that the charges on the two tapes were the same. We could reasonably assume this since the two tapes were charged in exactly the same manner. The charge based on the distributed charge model is far larger than that of the point charge model, which could be found in my lab playlist on YouTube. The reason for the difference likely has to do with the fact that the point charge model only considers the interactions of point charges with each other, whereas the distributed charge model considers the interaction of each and every small distributed point charge in one rod to each and every small distributed point charge in the other rod, and then sums all these interactions to find net force, which is larger as it takes into account all the relevant interactions involved, something which the point charge model doesn't do as effectively. The estimate of the charge produced by the distributed charge model is also most likely to be closer to the real value, as the distributed charge model more closely resembles real world conditions. Thanks for watching.